So reduced radical form, it covers several different operations, but has some general characteristics. We've actually somewhat seen this, don't write this, but back when, like if we had the square root of 120, and we split that up into two perfect square factor and a non-perfect square factor. In this case, what would it be? What would our nice perfect square factor be? And you can do it in phases. It doesn't have to all be at once, but... Huh? Neither of those are perfect squares, though.
What? Wait.
Okay.
9 and 24.
We'll do 4 and 30. Is there any other perfect square factors in 30?
No.
Okay. So then we would root the 4 and leave the 30. Okay?
No, that's what we're doing.
That was another version of reduced radical form. We are not doing that specifically. This is going to involve a lot more than just that. Okay, but this is part of it. Second thing, yesterday we talked, I didn't put it on here. Yesterday we talked about doing absolute value on anything that is an even root and ends in an odd power. Okay, but so that is true. We don't have to put it on numbers. I did that yesterday, but we don't have to, because we assume when we write the number that it's the principal root. Do you remember what that is?
Yeah.
Read your note if you don't. What is a principal root?
Somewhere just positive.
Yeah. So we're going to assume that if we pull out a number that it's positive. So we could have written this as just 2x squared y squared. Okay, why didn't we have to do these two in an absolute value?
Those are even exponents.
They're to an even power, which forces them to be positive, correct?
Yes.
Okay, and then this one, we had square root ending in rs. So we don't need the 4. It was good to think through yesterday, but now we're going to refine and leave it out of our, just the number out of our absolute value. Why do we have to put it around the r and the s?
They're not even odd.
They're to an odd exponent, which means they could be negative, right? So we force the positive. Okay, and then I think we had one more that was that way somewhere. Oh, it was after this. Did that one. It's down here maybe. Yeah. So that one we didn't need it on the 5. Do we need it on the end?
No.
No.
All right. And then looking at our warm-up, I forgot to ask you about this. So, do we need it on the 3, the p squared or q squared?
No.
Did we even need to consider it in this case? Why not?
Because it's to a third.
It's a third root or cube root, so that's an odd, so it's fine. Okay? How about over here? The d cubed needs an absolute value, the other two can stay out. Okay? Anybody remember to do that?
I
Do remember to do that. That is part of the story.
how you put the absolute value around like some of the numbers, like in the previous slides, like just the low numbers, or maybe I'm thinking of yesterday.
Can we
Like
just,
the 2.
Yeah, we don't need it.
Okay.
That's what I was just saying. Because we're going to assume the 2 is the principal root, and that means it's positive.
Okay, I was just wondering. Can we just put it on there just in case, like
No.
for always?
Don't do it.
Cool.
Alright. Maybe I'll just take those off if it's confusing. Oh, where'd it go?
No, we did not just do it.
What's wrong?
Okay.
Oh,
I'm
man.
mad that you don't fully erase it.
Got that one.
Or no longer should I do it? That's okay.
Alright. Got them all fixed. Anyway, so reduced radical form is going to involve multiplication. So how do we multiply radicals and then simplify? Or simplify, multiply, simplify again. Okay? It's also going to involve some division ones, like this. That one's really small. So how do we deal with simplifying that? There's some conditions that we have to make sure are true. Do you guys remember them at all?
Can you just put it on both of them?
You can, but
Okay.
that doesn't finish the job in most cases.
Could you change it where it's like A is, or is that just exponents where it's like n minus m?
Well, but you have to have the same base to subtract. Yeah, you guys don't get that mixed up. Okay, and then adding and subtracting as well, like this one. Okay, notice we have lots of different roots, like cube and squared, but also different radicands. So how do we deal with that? Okay, so all of that is part of reduced radical form. The stuff we've been doing, like this, just simplifying, is part of it. It will be kind of a last step in some cases. Sometimes it'll be an earlier step. So when we say reduced radical form, it involves all of those things. Any questions on that preview? Okay. There's going to be 3 conditions for reduced radical form. Maybe I'll just put a 3 there. 3 conditions. You good over there? Okay, first one. We want no powers greater than n inside. What is n? N is the index. Okay? So if your index is 4, you better not have any powers greater than that inside. That means you're not done yet. Okay? Here's an example. If we had something like x to the 6th, y to the 5th, that's not done.
Are we just going like each one gets something?
Yeah. Right, number 2. These next 2 are easy to get mixed up, so we can talk through them, but make sure you straighten them out. No denominators. I'm gonna make that plural. No denominators in the radical. So like the one I showed you a minute ago. Had n, I think, was in the denominator. No good. Okay. So make up some example.
You will 7s over, or under, oh my gosh, over x t. Yeah,
xt.
something like that, sure.
Okay, sure. So even though that one has no powers greater than n, it's still not done. I guess back on this one, on number 1, I want to give you a reminder. Prime factor any constants. Can we prime factor 7?
Well, no.
Like in that example, I mean.
Isn't it prime?
It is prime.
Yeah.
So can we prime factor it?
No.
Is 1 a prime number?
Yes.
1 is not a prime number.
Well, no, I meant no.
That's what I heard.
Yeah. Selective theory.
I heard that you said no.
Oh.
Okay.
My teacher used to say, I can't hear you unless you put your hand up.
So you can see how these are very similar in the way they read. No denominators in the radical, but no radicals in the denominator either. Those are different.
You know, like it can't be 7 over
So you can't have
5.
a fraction. Radical, and the radical part B in the fraction.
So let's just use that one. Well, hey, I took the quotient rule and split this up. Still not done. And to get it done is a little bit of thinking. So each time we do one of these, we have to think through those 3 conditions and make sure they're true. And then each, like multiplying, dividing, adding, subtracting, each have their own kind of nuances that we have to work through to get it done. And there's a little bit of work involved in some of those. So far we've really only been dealing with property 1 or condition number 1 as we've been simplifying. Can you give me a fist of 5 on that one? On just property 1.
Like how we feel about it?
How you been doing with it, yeah. That's the only one we've been using, is 1.
Like, okay.
So in my opinion, are we ready to, I think we're ready to move on to multiplication.
Yeah.
You guys feel that way?
Yeah.
Actually, before we write notes and examples on that, I want you to put I'm going to put it right here.
Only 1 for simplifying, multiplying, dividing, and adding.
Yeah. In other words, you'll have to be checking this every time you do one of these operations. That makes sense? Do you want notes on condition 1?
Condition what? Okay. Like an example?
No, notes.
Yeah.
Notes or, yeah, an example. Or
Isn't
notes.
that notes?
Yeah, either one. We can do them together.
Okay.
Sure, why not?
But didn't we just write notes about it?
No, we wrote what to do, or we wrote that you have to, but not how.
Oh, okay.
So would you like
Probably
to,
write how.
I mean, we've been doing it, but.
Oh, we have? I'm speaking. It's coming up.
I'm going to go back to that and write C examples in a second, but this is for condition 1, which we have kind of called jailbreak.
Oh. Okay, goodness. Okay, well.
Okay, what? Now you don't want it?
No, now I know what we're doing. I was a little confused. I thought we were starting something else, but I got it now.
I'll come on it.
All these files are a lot.
field trip to watch the Special Olympics.
You guys can. I'm not gonna take us all out there. But if you want.
Okay.
Do you want what?
Nothing.
Do you want an example or just a description?
Example.
Oh man.
I'm gonna write my own.
You asked. You proceed.
It's been a day already.
Yeah.
He's like, they went from my favorite to my least favorite all in one.
You know what? Let's change that to.
I thought he was gonna be like, you guys could never be my least favorite. He did not say that.
Change that to fourth so that we have to deal with some absolute value. Okay. So let's be very clear on this.
Dedication. You can root. Pull out.
I got target 3.
All right, you can root out or pull out anything in groups of n. Okay? How many? Well, let's prime factor the 90. Okay. That should probably be a reminder again.
I wrote 9 on
It's 90, yeah. Prime factor the constant. So 90, what goes into 90?
2 and 3.
Not 2 and 30.
3 and 3.
Okay.
3 and 7. And 2 and 5.
Alright, how many groups of what can we pull out?
One group of B and two of C.
Okay. So we're pulling out groups of 4. So we can do 2, and this is notes. Obviously you're not going to write this out every time, but this reminds you how to do it when you come back and look at that. Can you go put your phone in the box, please? Thanks. 2 groups of B. Wait, 1 group of B, not 2. 1 group of B. 2 groups of C. Thank you. Alright, so you're putting them out front with how many, the exponent is how many groups you pulled out. Okay, so I'm going to put out a B and C squared, and then 4th root. Is it, do I still need to have it all factored, the number, or can I rewrite it back as 90?
You can rewrite it.
Yeah, since none of those numbers came out, it might as well rewrite it back as 90. Okay? B what? Okay? So I'm going to use a different color for this because it's somewhat of a different step. So, and then how about C?
Just to the one.
Just to the 1. Okay? So any that were not part of a group, stay inside. Okay, last step, we just need to check if we need the absolute value. So we're pretty close to done with this one. Do we need absolute value?
Yeah.
Let's see.
On what?
On
Oh, yeah.
So any odd powers from an even root. So only the b needs it in here, okay? So absolute value of b, and then c squared. Or we could do c squared absolute value of b. The order there is okay. Scoot that over. And then 90 a squared b cubed c. So anything out front, just multiply like normal.
Hi on, have fun.
There, have fun.
I'm about to try it. Oh, sorry. I don't even have a job, so what would I do better? Being a kid. No more being a kid for you.
I think I'm definitely going to need more room than what this has.
Did I write it sideways?
Yeah, just knowing that, you might set it up slightly differently.
I'm guessing I'm gonna need to go
So
to
would
a
we
new page.
At the indexes?
I'm like speedily.
I'm saying
So it's kind of not something that you really think about doing. But I like that you're trying. That's good. Want to tell us how?
You multiply the index.
Ah, good thought.
You cross divide.
Let's get our example up here.
You first.
Simplify. And you add
Obviously you don't need the 2 on a square root, but I'm going to put that just
to show.
to make sure we know what the index is. Are you guys good with A's and B's?
No.
Yeah. A sounds great.
Let's make that smaller. Let's just do A. A,
Do they have to be small?
B. Well, this one will be cube.
Seven.
For our number.
Yeah.
74. 317.
27.
It's funny that we say 7 before we say 17.
I'm just trying to think of a good way to make this a good number to work with.
30.
Nine.
Probably shouldn't have picked 5 if I wanted to do that.
You could just pick like another 5 or, you know, like an even number and get a 0.
Get a 0.
Because 5 times 2 is 1 0.
It's hard to do in your tummy.
10. For 10
You're
days
really
after
mean
school.
today.
Easiest
I am
way
never
to tell
mean.
someone.
You could do 2 and then make it a 10.
I have a bruise. I have a lot of bruises.
Let's do,
3, 4, 7.
yeah, Yeah, I'm just gonna put something in here. To the next
Don't
one.
do an
Let's
odd
just do
number.
4. Okay.
You should check it on your AI to make sure that we can actually solve it.
Well, there's no solving. We're just multiplying.
Okay. How was that?
Alright, step
Are
1.
you okay?
Did you not see what they just did? It's funny.
So simplify first if possible. I wrote these so that we're not going to do that, but that's what you would start with. Okay? Like if I had written 5a to the 5th, pull out your a's, etc. Okay? Step 2. Rewrite each radical in exponential form.
Oh. Okay.
So what's this one going to be? And definitely, guys, for these next few steps, we want to use parentheses generously. Okay, so 5ab to the 1/2. How about the next one? Yeah. Probably could just do it. Good. 4a squared b squared to the 1/3. Okay. Can we do anything yet?
Not. Yes. You can just.
Can't, because we don't have the same base. Remember, our exponent rules only apply to the same base. Okay? So, our next step is to rewrite our exponents. Now we're rewriting again. With the common denominator. So, the left one, how's that going to look?
8 times
Wait, can I do it?
3
6
6.
over 2
3
3/6, yep. How about this one?
2 6.
2/6. Okay? Good so far? Okay. Well, now we have both of these to some, like if we think of m over n, back to when we had that on our first page of notes, remember we had m over n?
Yeah.
Okay, so does everybody see that this is something to the 1/6, something to the 1/6? They're both that way? Yes?
Yeah.
Okay. So step 4. Bring the bases with the numerator power inside parentheses and leave the denominator power out. Denominator power outside. Okay, write that and then I'll show you what I mean. So big parentheses to the 1/6. So denominator power outside. Inside, still have those parentheses around the 5ab. Those don't go anywhere. To the 3rd, and 4a squared b squared squared. Does everybody see how we did that step? Okay? It has to do, just pick a number. If it's a to the 3rd to the 1/6, Remember we multiply those. So we're just going backwards. That's all. Okay?
Okay. Sounds good.
Okay. Everybody good? Okay. So inside we're going to expand and simplify. What can we do in there? This is going to be a couple steps of this.
Can you like expand out 3 and the 2? Two different buddies?
No. Oh, yes.
What?
Yes, you can. Well, when you say it, I think of you're saying it wrong at first, and then it kind of sinks in. I'm like, yeah, I think she's right. Yes, that's what we can do. What? So this whole thing is going to stay where it is, like big parentheses to the 1/6. Okay? But this is going to be 5 cubed, a cubed, b cubed, times 4 squared, a to the 4th, b to the 4th. So we got rid of the 2 exponents inside. Okay, but this pink step, number 5, is still not done. Because what else can we do?
We can combine those. They don't have exponents.
So the whole big parentheses to the 1/6 stays the same. And yes, so 5 cubed, 4 squared, that's 125 times 16, right? Would you write it that way?
No.
Probably not, because we're going to prime factor it anyway, right? Right?
Mm-hmm.
Okay, so I'm not going to worry about it, but I will put those two together.
Oh,
Out
it
front.
came to us prime factor. That's nice.
Okay, well, in this case it did. It won't always. Like if I had changed this to 6 or something, then it's not prime factor, right?
Yeah.
A cubed times a to the 4th is what? A to the 7th. B cubed times b to the 4th is b to the 7th. Okay. Are we done?
No.
No, because now we need to simplify. We need to go back to reduced radical form, condition 1. Now you can use exponential or radical form. So which would you prefer? I mean, I'm not going to tell you which one to do, but just pick one that you like. I think we're more used to seeing this as a radical, right? But you don't have to do it that way. So you could rewrite this, obviously, as 6th root of 5 cubed 4 squared, a to the 7th, b to the 7th. But regardless, what's our result going to look like? A, one group of A. How many, by the way, are we putting in groups this time? 6. Okay, so A, one group of A, one group of B. This thing's having issues. Just give it a second. I'm not really sure what the problem is here. There it goes. Yeah. Okay, what goes inside?
5
2000.
Oh, okay.
What was it? 2,000?
102,000.
2,000 even? Oh, well then we probably should let's see, that's 2 to the 5th, that's close. So yeah. It's fine. 2,000 even, right? So,
Yeah.
Okay. And then A, B. What do we need to do to finish this off? We are not done.
What's the absolute value?
Why?
That's
6 through, and we end up with an odd power on both A and B. Okay? So what do you think?
Oh, this is interesting.
Totally different than if they had the same index, right? It's a lot more work.
Is this as hard as it gets?
Please.
Well, I guess technically this could have needed to be prime factored.
But then that's.
And then you pull out any numbers, right?
not
Then we're chilling.
In terms of process, this is, okay, so here's how I think of the stuff that we have to do. Since you're asking in terms of difficulty, I think from this green step down is all just procedural. So I don't think that's hard. It's just, you have to be careful because it's lots of steps. But figuring out the common denominator is, that's the critical step, like one of them. In division, like getting rid of or meeting those second 2 criteria, so no denominators in the radical, no radicals in the denominator, you have a step where you have to think critically to figure out how to do that. It could be harder than this.
Okay.
But it's no more steps. Yeah. So stepwise, this is probably the most. There's some solving that we'll do that's more than this, or maybe roughly equivalent. But otherwise, I think we're good.
Okay.
Yeah. Does that help you feel better?
High hopes for this unit's test.
Awesome.
I
You,
need
yeah,
it.
you better go knock on the tree outside.
See that cute?
Bro, we got a desert, right?
I saw the
It's just gonna be a
I saw the
love
hummingbird, it was cute.
He was so neat. He was on our front hummingbird feeder.
strike symbol.
Okay.
The test is just gonna be a quiz, right?
What is, okay.
It sounded like you were like depressed about that.
No, I'm happy. I love hummingbird.
Oh, okay.
That one's just stupid easy.
Well, what if we need
And the stupid easy ones be on the test.
No. All right, there you go.
my
Sorry. And,
On these, just make sure everything inside is taken to the power. Sometimes students mess that up. Okay, this is going to be 32x cubed. And we can rewrite that. 32 is, do you guys have it memorized yet?
2 to the 5th.
2 to the 5th, so we won't be able to pull that out. But do check. You know, if it happened to have been 64, you would want to get that 2 out front. And if you missed that, it would be incomplete. So, like, I don't know if you heard Gabe, but he said you can't pull anything out of this one, which is true.
I messed it up.
How'd it go for you? Great. Okay.
Everything's like good. I don't know. I just forgot to distribute the 2 to the other 2. So I made it 4x squared.
Okay. Do we want to start this, or do you want to do that tomorrow? Do you feel like you need some time to work on this kind of stuff?
I feel like we need to
Time.